This is limits on graphs.
Yes, and you're never going to use this in your life, but I've got to teach you on it anyways. So, limits of graphs. We just taught you how to do it algebraically. Now, what if they give you a graph and they're like, suck it, you don't know the equation, try to find out these limits? Well, simple thing, just look at it. It's not that hard. So, limit as x approaches 0. Remember what I said at the end of the other video? If you even watched it or care to watch the whole thing. If you haven't, you need to go back and stop skipping over it. As x approaches 0, as you can see, it starts to hit 0. So, the answer is 0. Negative 1. As you can see, they both come into... Hey, look at that, negative 1. This is when things start getting tricky, though. Not all graphs you're going to come to are going to be continuous. And that will be talked in a much later section. But as you can see here, if I'm coming to 1 from both sides, this stops at 1. If I come to 1 at both sides, they don't meet at the same point. Which means there is no answer. And these are the ones that the algebraic ones are going to work for. So it does not exist. So in any test you put D-N-E does not exist. Or D-N-E.
Sounds nifty.
Now, if you do have a D&E, they're most likely going to ask you these as well. You're probably looking at that thinking positive and negative. Well, if you think about the graph, the left side is negative. The right side is positive. So if I'm asking you as x approaches 1 negative,
it's from the left.
It comes from the left. If I'm asking you about 1 positive, it's coming from the right. So the answer, you don't have to worry about where it's coming from the right on this one, because it's coming from the left. As you can see, it's coming up to point 3. And as you look at coming from the right, it's hitting 1. That's just simply looking at a graph, and these are all very simple things. Most of this whole thing will be simple questions. We ain't gonna give you too many hard ones, because you're looking at a wiki space, not a textbook. Stupid. But let's look at something else here. I really don't know if you're gonna learn about this in a later chapter or later section, but what happens if you have a graph at x equals 1 that does this? Or a graph that at 0 does this?
Those are graphs that approach infinity.
These, of course, as x approaches a certain number, 1, since they're both going to positive infinity, you can say infinity. These do not approach the same way
as the limit approaches 0.
As the limit of x approaches 0. So you have to say D&E.
D&E.
Now, let's say you have another graph way over here. Zoom in on that. And I asked at 1, 2, let's say at 2, and this graph goes like this. Never touches 2. Let's just say there's an asymptote that you finally learned was there, whatever. And it slowly gets closer if you know anything about asymptotes, which you should!
Being an AP calculus.
Yes. And I asked you as the limit of x approaches, can you guess it, J-Man?
0.
No.
2.
Negative infinity.
Negative infinity.
Thinking, what the buns am I looking at here? Well, as it goes to negative infinity, what is it reaching? Now, whenever, here's a little tip for you. Whenever x approaches a realistic number,
that's the limit.
It can go to a number or infinity or negative infinity. But if it ever goes towards an infinity,
it's approaching
most
asymptote.
of the time is going to be going towards an asymptote, unless you get a graph that's going to be like, yeah, like that. I mean, it's going to go to infinity. But most of the time, you're going to have an asymptote, and they're not going to be D-bags about it. Anyways, those are basically asymptotes of graphs. These are basically...
The answer to that would be actually 2. But you didn't write that out.
Which one?
Right there.
Yeah, the answer would be 2. I'm sorry, 2 equals 2. Yes. Well, this is basically brushing the top of it. You got places where it won't work, places where it does, infinity, not infinity, well, both infinities, how to look at it from a graph coming from the left and the right, and all that stuff. This is basically all the basics, and you can go into crazy stuff where they don't even matter. So that's limits on graphs. See you next time.
Beep.